Good morning. Actually, Professor A.K. Chaturvedi, sir, my seminar guide, Dr. Vikas Bansal, sir, seminar coordinator D.P. Sharma, sir, faculty members, examiners, and my batchmates. I am Rahul Sharma, pursuing my B.Tech from University Department of Mechanical Engineering, Rajasthan Technical University, Kota, Rajasthan. I am here to present my topic advancement in anti-radiation missiles. Let's have an overview of the presentation. It includes introduction, history of missiles, world's first rocket, classification of missiles, development of anti-radiation missiles in the world and India. Anti-radiation missiles is a kind of hard-kill electronic attacking weapon which uses radar and signal radiation sources as targets. It detects, identifies, locates, and attacks radars by receiving radar signals. So it is called radar killer. In order to resist the anti-radiation missiles, attacks a variety of target defensive measures are also emerging, such as the use of bistatic radars, low probability of intercepting radars and active decoys, etc. Early anti-radiation missiles such as the AGM-45C were not particularly intelligent. They could simply home in on the sources of the radiation and explode when they got near to it. Surface-to-air missiles operators learned to turn their radars off when an anti-radiation missile was fired at them, then turn it back on later, greatly reducing the missile's effectiveness. Now, coming on to the history of the missiles. The use of the missiles date back in the Vedic age in India. Indian warriors have used astras as missiles in various forms that period in the subcontinents, fruits of which can be drawn from a number of epics such as Mahabharata and Ramayana. In olden days, the astras were controlled by mantras that could be correlated to the missile control system or software of the modern day missiles. Now, coming on to the world's first rocket or the missile. Fighting the British colonial army, the Tipu Sultan and his army used thousands of rockets, resulting in the defeat of the troops in the Srirangapatnam War in 1792. The rockets were attacked with bamboos or steel spears and powered by the gunpowder, propellant compacted in a cast iron chamber with nozzles and igniters capable of attacking enemy cavalry and soldiers. Now, coming to the classifications of the missiles, presently there are many types of missiles. They can be broadly classified on the basis of their features, such as types of targets, mode of launching, system adopted for control, propulsion or guidance, aerodynamics, etc. On the basis of targets, they could be classified as anti-tank or anti-armor, anti-personnel, anti-aircraft, anti-ship, anti-submarine, anti-satellite or anti-missiles. Classifications based on the methods of launching. Surface-to-air missiles, SSM. Surface-to-air missiles, SAM. Surface-to-surface missiles, surface-to-air missiles, and air-to-surface missiles. Some of the air-to-surface missiles which are in India are BrahMos, Harina, Dhruva, Sun, and Rudram-1. Coming on to the BrahMos missile. The BrahMos missile is a medium-range, clumsy supersonic cruise missile that can be launched from submarines, ships, aircrafts, or land. It is the fastest supersonic cruise missile in the world. It is a joint venture between the Russian Federation NPO and India's Defense Research and Development Organization DRD, who together have formed BrahMos Aerospace. It is based on the Russian P-800 Onik supersonic anti-ship cruise missile. A hypersonic version of missile BrahMos 2 is also presently under development with a speed of Mach 78 to boost aerial fast tracking capacity. India and Russia intended to make 2000 BrahMos supersonic cruise missiles over the next 10 years through their joint venture company. Now coming to the Nag missile. The Nag missile, also called Cosmina for the land attack version, is an Indian third generation all-weather fire and forget, low-on after launch, anti-tank guided missile with an operational range of 500 meters to 20 kilometers. It is a single shot high probability of 90% and a 10-year maintenance life. The Nag has 5 variants under development: a land version for a mast-mounted system, the helicopter-launched Nag, Harina, also known as Dhruva, man-portable version, MP-ATGM. Now, coming to the development of anti-radiation missiles in the world, the development of anti-radiation missile has gone through 3 generations. The first generation of anti-radiation missiles is the typical representation of the United States AGM-45 type missile. Since the battlefield has made brilliant achievements in the Vietnam War, it took the fatal blow to the Vietnam military light radar. To the second generation of anti-radiation missiles, it has made a considerable improvement in the performances, seeker bandwidth increases, intercept radar signals, frequency and band extensions, high receiver sensitivity, and can be guided by the radar beam signals. The third generation of anti-radiation missile is based on the actual combat. All aspects of the performance are improved effectively, covering almost all the radar frequency bands with a high flying speed range for the power of the characteristics. Seeker responsive strong anti-electromagnetic interference capability can solve the problem of the target radar suddenly shutting down. The US military is equipped with AGM-41, AGM-78, AGM-88 and AGM-136 as well as missiles of the carrier-based missiles. Other Western countries have also joined the ranks of R&D with the US Army to compete, such as the British Alarm Mission, Russian AS-6, AS-9 and AS-11 and other missiles. Now, coming to the passive radar seeker. Passive radar seeker is the core component of the anti-radiation missiles. It is mainly composed of the target selection system, gain control system, signal forming system, state conversion system and so on. Among them, the target selection system is one of its core. Its main task is to search the radar, identify and measure the angular coordinates and classify. Advantages of the passive radar seeker. Characteristics of the passive radar seeker: width can be deep with the frequency, agility radar and good frequency selectivity. Can be effective for the strong sorting, processing, target detection and recognition. So it can deal with almost all of the foundation's control system. Defects of the passive radar seeker. Passive radar seeker sensitivity is mainly determined by the directions of the receiver part and the signal separation and selection system. To receive the frequency, agile radar signals, the bandwidth of the receiver is usually 500 MHz. The sensitivity is low and the active ability is poor. There is an inherent flaw in the passive radar seeker. Passive radar seeker and target signal mismatch. PRS, passive receives types of unknown radar signals so that the PRS receiver cannot match the receiver signal. Now, coming to the development of anti-radiation missile in India. The first missile of India is the Rudram 1. The Rudram 1 is an air-to-surface anti-radiation missile in the development by the Defence Research and Development Organization of India. It is primarily meant for the suppression of enemy air defense that can be launched from a range of altitudes with large stand-off distances for destroying enemy surveillance radars, trackings and communication systems. It is first anti-radiation missile developed in India and will be jointly produced by the Bharat Dynamic Limited and Bharat Electronic Limited after trial and introduction. Development had begun by April 2011 at Defence Research and Development Laboratory. The project was officially approved in December 2012 with a budget of 317.2 crores. The feasibility studies were done in 2012 and 2013 with the aim is to develop a fully indigenous tactical anti-radiation capable missile for the Indian Air Force, which is comparable to AGM-88E, AARGM, MAC and other missiles. Rudram family. Rudram family consists of 3 missiles. Rudram 1 being the first anti-radiation missile in the family that weighs around 600 kgs and an operational range of 200 kilometers. Rudram 2 is an upgraded air-to-surface missile with 800 kg weight and range of 300 kilometers to be used for destroying heavy fort-like military installation and facility. DRDO also in developing Rudram 2A. DRDO is also working on Rudram 3, which will be a 1-ton hypersonic aero ballistic missile carrying conventional warheads with a range of over 500 kilometers. Rudram 3 will cruise at Mach 5. Now, coming on to the conclusions of my PPT and my presentation, anti-radiation missile as a radar killer is the future of electronic warfare, essentials to the winning the magic weapons. To master the anti-radiation missiles, who would account for the war's opportunity. And these are my references from which I took some of the help, and I hope you all are clear. If you have any question, then you may ask.
When Rudram will be deployed in the services?
Okay, Rudram will be deployed in the services by the end of 2022. Thank you.